Alright, now that we've practiced finding z-scores for just one piece of data, such as like Jeff and his basketball game, we're going to start looking at where those really come in handy. And those really come in handy when we have two like things that we're trying to compare, but they have very different ways of actually scoring those or comparing them. For instance, this problem here says Rachel is trying to decide whether she should send in her ACT or SAT scores for college. She wants to choose the one that makes her look the best. Both tests are normally distributed but are scored very differently. A perfect SAT score is 1600 and a perfect ACT score is 36. So we can already see there's a problem here. The SAT has a lot more points involved in terms of a perfect score, and an ACT is just kind of like up to 36. So how do we know which one is better? Because obviously a lot of the SAT scores are going to be higher than 36, but does that mean she did really better? So what we're going to do here is we're going to look at her two scores and compare those to what the average person did this year. So it says the average SAT score this year was 1,050 with a standard deviation of 130. The average ACT score this year was 24 with a standard deviation of 1.2. She scored a 1,350 on the SAT and a 27 on the ACT. Which test did she do better on? So now we're comparing apples and oranges, but with normal distribution and a z-score, we can actually compare these two things to see which one she did better on. Which one was she more not typical? Was she right in the average area, or was she doing really better on another one? So what that means, though, is we're going to have to do two normal distributions and compare those and find our z-score. So one thing I find helpful is to make your normal distribution curve just a sketch. Doesn't have to be perfect. They very rarely are. And we know there's a mean and 1, 2, 3, 1, 2, 3. And we'll say this is her ACT curve. So the ACT average was 24 and had a standard deviation of 1.2. So this is 25.2, 26.4, 27.6. And then if we go down the other way, we get 22.8, 21.6, and 20.4. So that's her ACT curve. And it says on her thing that she scored a 27 on that. So 27 is way up here. So already we're kind of in that good zone. She did really well, it looks like, on that. But we can't necessarily say, oh, let's just choose the ACT because that one looks good. We have to compare that to our SAT. So I'm going to make my SAT curve. Mean 1, 2, 3, 1, 2, 3. And the visual usually helps out a lot of people. Okay, and it says the average here was 1,050 with a standard deviation of 130. So that means this is 1180. Then if we add 130 to that, that's going to put us at 1310. And then 130 to that, 1430. Okay, so that's going to be 920, 790, and 66 or 660. Okay, so this is her SAT score curve. And it says that she scored, I'll highlight these just so we can keep track. So the 27 on the SAT, and she scored a 1350 on the SAT. And so 1350 is about right there. So if we're looking at our curves and we're looking at that typical, unlikely, highly unlikely zone, we're going to find out that she is in this really good zone right here. Okay, remember that's where we said, wow, that's really good. Like, that's highly unlikely that someone does that well on something. We're in the very high ends of our percentages. And they're both in there. So does that mean they're both equally great? Well, as you can kind of see, that 27 looks to be a little bit further than the purple, but these are just estimations. So do we really know that the ACT is better than the SAT? Well, we think it is, so let's try and prove that. And the way we're going to do that is we're going to find the z-score for both and compare them. So on this one's z-score, she scored a 27. The average was 24. And our normal distribution here was, what was it again? 1.2. On the other z-score, the average was 1050 and she scored 1350. And the normal distribution, or standard deviation, sorry, was 130. So now we're just going to do the math of this to come up with what those z-scores are. So if we do 27 minus 24 divided by 1.2, let me put that into my calculator real quick. We get a z-score of 2.5. And if we do the other one, which is going to be 300 divided by 130, we get a z-score of 2.3. So if we're looking at those z-scores, we can now compare the two scores to see which ones did better. And obviously the higher the z-score, that means you're going to be higher on your normal distribution line, and that's going to be more unlikely. So should we choose the ACT or the SAT? Well, it turns out that her z-score right here is bigger than the one down here. So if it has a bigger z-score, that means she did a lot better than most people on here. She has all of this that she's better than. Okay, those are all the other people's scores. Whereas on this one, she only did as well as these. So you can see that there's going to be a little bit more of the curve shaded in on the ACT than the SAT. So we can say that she did better on that. So when we're comparing two unlike things that have very different scoring systems, we want to look at the z-score, and that's going to tell us really whether or not we did something well, or if it was typical, or if we did something really well or really bad, and that's how we're going to compare those. And we're going to be looking at those comparisons in your practice to help get you ready to do that.